Geometry, translations. So prior to this, we've discussed two types of rigid motions, reflections and rotations. And the constructions for them were pretty basic. It was really, at least finding the line of reflection and finding the point of rotation was really just a bunch of perpendicular bisector constructions, and we didn't do a whole lot with those. Translations are a little bit more advanced when it comes to constructions, but first we have to kind of talk about what a translation is. You know that reflecting is like a mirror image, and rotation is turning it around, pivoting around a point, and so on. Translation translation is not a word I think we use in our everyday language, at least not to mean this. Sometimes translation is, translating a language from one language to another. But translations in geometry basically means to shift a figure in a direction. And the direction we call a vector. A vector is like saying like up, down, left, right, and by how much. So the vector is the direction of the shift. Ooh, very sloppy. Hold on. Direction of the shift. So the direction of the shift is what we call the vector. And we use an arrow like this to represent that vector. And so if you see an arrow like that, it's saying move it down and to the right. But not only that, we're moving it down and to the right by this length. So the vector is not only the direction we shift, but also the length of the shift. So it's the direction and length of the shift. And so that's what a translation is. Move this to the right and down 5. To the right, 3 units and down 5 units type thing. Now we talk about units, that would be something like on a graph. But if we're just using a compass, but it's a specific direction by a specific length. That's what a translation is. But nothing's being spun, nothing's rotated, nothing's being flipped. Orientation is still the same, things like that. So this figure just wants us to draw the vector, and the solid line is the original. The dotted line is the change. And so for a vector, I'm going to use an arrow that starts with a point and ends with an arrow. And all you have to do to draw a vector is go from one corresponding point and then send the arrow to where that corresponding point would land. So that's your vector right there, because this figure, this little mountain figure, got shifted to the left this length. And if I were to, clone this, I would see that that length is, and that vector is appropriate for all corresponding points. They go there, these corresponding points went there, and these corresponding points went there. So for every corresponding point, the translation, the vector translation is going to be the same. So just drawing that vector is pretty simple. All right, on a figure, I have this little square here, RSUT, and I want to translate it 2 units down and 3 units left. So every point go down 2 and 3 to the left. So starting with point R here, I'm going to go down 2 and left 3. So that's going to be my R prime. And S, down 2, left 3. That'll be S prime. U, down 2, left 3. That would be U prime. And here would be T prime. And I'll just use my line tool to connect my dots. So that's my square, my prime square. And so that's really it. And then this is T prime. Let's put the vector here. It doesn't say to do that, but what would be the vector? The vector was down 2 and 3 to the right. I could do it by connecting points, but I could also do it off the grid. What was my vector here? My vector was starting at a point, I went down 2 and left 3. So that's what my vector would look like. This was the vector of the translation. That was down 2, left 3, starting at a given point. And I see every one of these figures did that translation. All right, so how do we do this with a compass and a straight edge? Because that's really, the construction side of it, and that's a little challenging here. All right, so I have this line here. I'm going to call it line CD. And I want to translate it by this vector. So I'm moving it perfectly to the right this length. So how do we do that? All right, so first of all, I need my compass. the first thing you want to do, step one, is to measure the vector. And we know we need to always make a slash when we measure the vector. So step one is measure vector. Step two is arc that vector at each point. So I'm going to say arc the vector radius, arc the vector radius at each point. What does that mean? So what that means is this is my vector radius. I got that by just setting my compass to be the length of the vector I want to translate. I'm going to use that radius to draw arcs around each point that I want to translate. So I want to draw like kind of half a circle like that around each point. And what this is really doing is, remember what a translation is saying. It's moving a figure. And I want to move by this length. So what I'm doing is I'm putting these arcs here that any point on this arc is this length. Any point on this arc is the length of vector AB. And so if I were to put it here, I would be moving by length AB. I'd move point C by length AB. If I were to go here, I'd be moving D by a length of AB. Now, so I want to know that length. I got that part set, but now I have to figure out the direction side. Because remember, a vector is length and direction. We just took care of the length side of it. But I need to know where on this arc does point C go? Where on the arc does point D go? I can't just say, oh, it's probably over here, which is true, but specifically, and I need the construction to show me. All right, so this is how you do the length side of it. How do we do the direction side of it? Step 3. Okay, so what we do is we pivot, or we measure the distance. Hold on one sec. So we measure the distance from the point to the beginning of the vector. I'm actually going to flip this around. So put the pivot at the beginning of the vector and extend it so that it's at the point you want to translate. So that's the first step, is measure the length, the distance between the vector start to, let's see, the point, because we have to do this one at a time for each point. So measure the distance between the vector start, the beginning of the vector, to each point. So I want to move point C. I need to know the length between this, but then I draw the arc from the end of the vector, like that. And so step 4 is draw or arc that length from vector end. Okay. So I'll do it again for this other point here. So first thing I have to do is set the length to be from the start of the vector to the point I want to move. It's going to be close, just making it. From the start of the vector to the point I want to move, but then I draw the arc of that length from the end of the vector. Okay. Where those arcs cross, we place points. Here it's pretty obvious. But if I were to extend this arc and extend this arc, it does cross twice. Like it crosses twice here. So you have a choice between which of these it's going to be. And you can usually tell that this vector is kind of straight to the right. So it makes sense that it would be over here. This over here would be a little bit down too much. So that doesn't make a lot of sense there. That is our translation right there. Connect your dots. That's it. And then let me label that C prime in D prime. And then I want to recap this one more time. I know I'm at my 10-minute mark that I like to stay with. And so this is the distance part of the construction. Oh, the direction part, sorry. Direction. So the first part is to measure the length that I'm going to move the point. It's just going to be the length of the vector. So you set your compass to be this length and draw that arc around each point you plan to move. That's the easy part. Then you set your compass to be the length from the point you want to move to the beginning of the vector, but you draw that arc pivoting at the end of the vector. Where the arcs cross, that's your point. Same thing for each point, but that is going to be a different length for each point because each point is a different length to the vector that you're provided. So set it to be the length of the beginning of the vector to the point, but then draw the arc pivoting at the end of the vector. Where they cross, that's how we go about that. We're going to practice this a great deal in class and try to do this. This is, I think, a more challenging construction by far than the reflections and the rotations we've done so far. This may be the most complicated construction of the course. It's not too bad once you practice it enough, but we'll definitely get a lot of practice with this one. See ya.